Let's take a look at the following absolute value inequality. We have the absolute value of x minus 2 is greater than 6. All right, now there's a little bit more in the absolute value bar. There's actually an extra term that we've been seeing in the previous section where we just had the absolute value of x. We have the absolute value of the expression x minus 2. So what we're going to do is we're going to rewrite this as a compound inequality and solve it separately. So let's go ahead and rewrite this as x minus 2 is greater than 6, or x minus 2 is less than negative 6. All right, we saw this in a previous section when we're solving compound inequalities, where we rewrite them in two different cases. All right, we have two separate cases here, so let's go ahead and solve them. Let's add 2 to both sides for this first one. That'll give us x is greater than 6. That's our first possibility, or our first interval. And let's go ahead and add 2 to both sides over here. So we have x is less than minus 6, and a positive 2 is just a minus 4. And that's our second interval. All right, so let's go ahead and put this on a number line. Not a whole lot to these. We're just using what we learned in a previous section. 0, 1, 2, 3, 4, 5, 6. That's 6. 2, 3, 4. That's minus 4. Okay, so we want all the values that are less than minus 4. So to the left of minus 4, but not including minus 4. So we're going to include a parentheses here to exclude the value minus 4. And just shade to the left because we want the values less than. Now we want all the values that are greater than 6, not including 6. So we'll put a parentheses at 6 to exclude it, and just shade to the right to give us all the values that are greater than 6. All right, let's take a look at another one. Say we have the absolute value of x plus 4 is less than 2. All right, so we want to know for what values of x, when we add 4, gives us a distance of less than 2 units from 0. That's another way to read these. So let's go ahead and split it up into a compound inequality and solve them separately. So we have the expression inside the absolute value bars is x plus 4. It can be less than 2. And it also, since we have a less than sign, we're going to have an and inequality, right? We saw that in the previous section. We have a greater than sign right here. Anytime we have greater than or equal to, we're going to have an or inequality, giving us two separate shaded regions. Anytime we have a less than or equal to sign, we're going to get an and inequality, which means we'll have one shaded region. So we do need to remember that. So this is our first possibility, x plus 4 is less than 2, but we also want to know when x plus 4 is greater than a negative 2. All right, so we want the value of x, which makes the distance of the expression less than 2. So from 0, so 2 in the negative direction, which is minus 2, and 2 in the positive direction, which is plus 2. We should have a pretty good handle on this by now. So let's go ahead and solve these. Let's subtract 4 from both sides, which is x is less than 2 minus 4 is minus 2. Do the same thing over here. These two terms cancel, so we have x is greater than minus 2, and minus 4 is minus 6. So we have x is greater than minus 6. Let's go ahead and plot that on our number line and see what it looks like. We should have one shaded region overlapping. Let's put 0 over here. 1, 2. Excuse me. Let's rescale this. We're just dealing with negatives, right? Let's go ahead and put minus 2 here. 1, 2, 2, 3, 4, 5. There's minus 6. And that's really all we're dealing with here. We're not worried too much. That's messy, I apologize. We're not worried too much about the positive direction. So we want all the values that are less than minus 2, not including minus 2. So let's put a parentheses here opening to the left. In that same region, we want all the values that are greater than minus 6. And we're not including minus 6, so let's go ahead and put a parentheses there, and we're shading in between. All right, in inequality notation, if we go ahead and write it like that, we have minus 6 is less than x, which is less than 6. That's the inequality notation of this solution graph and this inequality, or absolute value inequality. All right, so we should be very familiar with that by now. Let's do a couple more just for practice. Let's say we have the absolute value of x plus 1/2 is less than or equal to positive 3. All right, so we have a less than or equal to sign, which means we have an and inequality, which means we're going to have one solution interval. So let's go ahead and write the two possibilities. So we have x plus 1/2. It can either be less than or equal to 3, and we want the solution interval where x plus 1/2 is greater than or equal to a negative 3. All right, so let's go ahead and I forgot to write 3 here. All right, there we go. All right, so let's go ahead and subtract both sides by minus 1/2, or subtract both sides by 1/2. So we have x is less than or equal to 3 is the same as 6 over 2. 6 over 2 minus 1/2 is a positive 5/2. So that's our first endpoint. We want the other one as well. So we have minus 1/2 from both sides. Let's separate this. Those two terms cancel, so we have x is greater than or equal to minus 3 is the same as minus 6 over 2. So minus 6 over 2 and minus 1/2 is a minus 7/2. So our inequality notation, we're going to have minus 7 over 2 is less than or equal to x, which is less than or equal to 5 over 2. Or also read, we want all the values in between these 2 points. So let's see what that graph looks like. That goes out negative infinity. That goes out to positive infinity. 0, 2, 3, 2, 3, 4. It's minus 4 out here. I'm just write in a few. Okay, so we want all the values in between minus 7/2. So let's start with that one. We're going to include minus 7/2, which is 3/2, or minus 3/2, excuse me. So we're going to put a bracket right there. And it's going to open to the right because we want all the values of x that are greater than or equal to minus 7/2. And we want all the values that are less than or equal to positive 5/2, which is right here. We're including a positive 5/2 in our interval, so we're going to put a bracket there and just shade in between. And that's our solution interval for the absolute value inequality. All right, not a whole lot to these. We really know how to do these already. We just want to look at the absolute values as the same as we did earlier. Let's go ahead and look at another one. One more. We have 2x minus 2 is greater than or equal to 1. All right, so we have two different cases here. We have a greater than or equal to sign, which means we're going to have an or inequality. So let's go ahead and write those two cases. So we have 2x minus 2 is either greater than or equal to 1, or 2x minus 2 is less than or equal to minus 1. All right, it's very imperative that you know how we're getting this. So go back and review our section on compound inequalities, or just review this section again and get some more practice. So go ahead and add 2 to both sides. Those two terms will cancel. We have 2x is greater than or equal to 1 plus 2 is 3. We can isolate x by dividing both sides by 2. So we have x is greater than or equal to 3/2. All right, the next case is this one. We're going to solve by adding both sides by 2. So we have 2x is less than or equal to minus 1 plus 2 is a positive 1. Let's go ahead and divide both sides by 2. I'm just running through these because this is simple algebra that we actually already know how to do. We should be very familiar with it. So we have x is less than or equal to a positive 1/2. So we have two cases. We have x is greater than or equal to 3/2, or x is less than or equal to 1/2. So we're going to zoom in quite close on our number line. Here's 0, here's 1, here's 2, and going in the negative direction. So we want 2 intervals. We're going to have 2 shaded regions. We want all the values of x that is greater than or equal to 3/2, which is right here. All right, so we're going to have a bracket because we're going to include 3/2, and we're going to shade to the right. Those are the values greater than or equal to 3/2. And now we want all the values of x that are less than or equal to 1/2. And we're including 1/2, so we're going to put a bracket here. And we're going to shade to the right, to the left, which is all the values less than a positive 1/2. So not a whole lot to these. Be sure to review this section and the previous sections on absolute value and absolute value equations, so you can get a good handle on this. We'll do one more video. We'll look at a few more complex absolute value inequalities just for a little bit more practice. So I'll see you in the next video.